Hi, I'm Toni and I work at Wolfram. Today we are going to talk about an implementation of RDF and SPARQL in the Wolfram language. You are going to see how to represent symbolically RDF data and query it using SPARQL. Hi, I'm Toni. I work at Wolfram and I'm working on RDF and SPARQL. Who of you knows what that is? Okay, great. Who has queried a SPARQL endpoint before or worked with RDF data? Well, okay, not so many. So let's introduce these things and first motivate why we want to do that. So let's see what we did traditionally. If we wanted to, say, make a plot of some data, we got some spreadsheets and somehow imported the data and then made a plot of it. And then when we wanted to compare this curve to some other data, we would probably get another spreadsheet and do the same process again and then plot it in the same plot. And if you're not lucky, the curves would be totally separate. And why is that? Because the units were missing. And you have to manually find them in the documentation of your data set. The emphasis is on manually. So now, how do we do that now? So an example, we want to plot a map of things around us. How would we do that now? We find a data source, in our case, a so-called SPARQL endpoint that contains a lot of data. We write a query that finds places around us at a certain center, in a certain radius. And the things that it finds are certain objects. And we want the human-readable labels for these objects, so we also define a label query. And then we put everything together. We want to find things around here in a radius of 1 kilometer and the labels. And we send this query to our SPARQL endpoint that we chose. And we get back some results. And then we can plot the whole thing in a map. And what we see is, for instance, the Illinois terminal. So how was it possible that this data could be shown in a map directly? It is because the information that came back, stored in the variable location, was something that is meaningful to the Wolfram language, so it could directly show it on the map. And we are going to see how that works in general. So the overview of this talk is I'm going to introduce RDF, the resource description framework, that is used to describing information. Then SPARQL, which is the query language for RDF, and then some future features that build on top of that framework. So RDF, the resource description framework. Everything, say Albert Einstein, is a resource. To attach information to that resource, we create a so-called IRI, a resource identifier, or internationalized resource identifier. Because everything is a resource, even properties that we use to label or describe these resources, they are also IRIs. So they have properties themselves, and so on. And then there are some special things, like literals. If you just have a string, you don't know what it means on its own. But in RDF, each string is annotated with a data type, and in this case, it uniquely defines how this string is to be interpreted, namely as a temperature in degrees Celsius. Now that we have the basics, we can start making statements. As you have seen before, this was a short IRI, but they are usually longer because they have to be unique globally. So I introduced some shortcuts. Let's see, for instance, WD of Q1 gives me an IRI in Wikidata. And I can even click on it, and I get a human-readable description of that IRI. So this IRI identifies, stands for the universe. So now we can make a statement. This thing is of type person. So that means Albert Einstein is a person. It's a machine-readable statement. And then we can collect these statements into RDF graphs. This is an RDF store which contains one or more graphs. Yeah? So, and now that you have these identifiers, you might want to find some information about them. Yeah? One way is to click on it to get human-readable information. The other way is to retrieve an RDF representation of the information associated with that item. So, this is one example. I just resolve this IRI and say I want an RDF representation. Turtle is one of the possible serializations of RDF data, and I get back an RDF store. And it doesn't just work for Wikidata, my favorite example, but any other, let's say, protein data. Or here I have an IRI about seconds. Yeah? So what kind of seconds? This standard defines exactly what it means. So once we have a machine-readable information about these resources, what can we do with them? So that's where SPARQL comes in. Because you could look at the triples that are in the store, but this is not the most useful way to look at it. Usually you might want to ask more complicated questions, and that's what SPARQL is for. So a quick crash course in SPARQL. So here I have some RDF store that I got from somewhere. Maybe I imported it or created it myself. And then I want to ask to explore it, what are the properties in it? So the syntax is you usually have a so-called graph pattern or basic graph pattern, which is a list of triple patterns. Here I have just one triple pattern, and these question marks signify the start of a variable. You know? That means here we have a triple pattern that matches any triple in that store because we have 3 variables. And then we want to know only the predicate variable, the one in the middle, and we want to eliminate duplicates. So that's how we see what kind of properties are in that RDF store. Yeah? For instance, a property called works at or knows. Yeah? And now, as a second example, we can ask the same question, but what kind of subjects are in this RDF store? Yeah? We see, let's say, Toni or Paco or Andrew. Yeah? And then we can ask, where does Toni work? Yeah? We have a triple pattern. The first is an IRI, not a variable this time. This one is a property. And this one is a variable, and we get back, well, works at Wolfram. Yeah? And now we can go a little bit more complicated, find all the people that work at Wolfram. Well, it's a fake store. We won't find everybody, but yeah. And then for these people, find the name. Yeah? In this case, label. Yeah? And we get a list of people. So the way to think about SPARQL queries is one object connects to another object, and that might connect to further objects. For each of these connections, you just write down a triple or a triple pattern. Yeah? Wherever you don't have a literal, you put a variable. And that's it, what you have to know about writing basic SPARQL queries. So what can you do with these SPARQL queries? Later, I'm going to show you some more features of SPARQL, but this is the basic. Yeah? So let's define a query that counts the triples in an RDF store. Yeah? And here we have, again, a local RDF store. And we apply this query to this store. And we get out, yes, 4 triples. We can also execute this query on a remote SPARQL endpoint. Yeah, in this case, Wikidata. And we send it there and back there, get back the answer. Yeah. Just changed since yesterday. Fine. The other distinction is symbolic versus query strings. Our main feature is the symbolic queries. But in some cases, when you're writing queries manually, you would probably use a query string. So with that query, that I'm sending to Wikidata, I'm retrieving for caffeine, the chemical formula, and the image. I can execute it. Well, it's the same as yesterday. Yeah? But I can write the same query in symbolic form. Yeah? So here you have a SPARQL select query with a list of triple patterns. Yeah? Here, this is caffeine. This is the formula. and this is the image. And you get back the same result. When would you use a symbolic query? When you start writing data-driven applications, you would compose complicated queries from smaller components. Yeah? And that's when you use that. So, what does, yes? That is the SPARQL endpoint. Yeah. So some of the SPARQL features, we have basic graph patterns like you have already seen. So here 2 triple patterns, and you have a condition on that, for instance, to find books published before 1980, whatever. Or you can find all the books, and if available, the year. So this is an optional pattern. You can have union patterns, like either that pattern or that pattern. No need to understand this. It's just a quick overview of the features, the power of SPARQL. Yeah? You can have negation. For instance, find all the people that don't have an email address specified. So you can ask them later. Yeah? Property path. This is an exciting feature of SPARQL, in which you can start at a certain node. It can even be variable, follow along a path along certain properties. Let's say any person that has a father, you know, and then where does the father live in? You know? So, or starting at a person, Tom, and follow one or more edges of the property nodes. Yeah? So that means find a big circle of friends of Tom. Yeah? Or aggregates, you know? The number of books by author. Yeah? Subqueries. Federation is an interesting feature. That means you might have a data set and query it, and it might link to another data set from which you want to retrieve additional information. That means part of the query, let's say you have some items in your database and they link to Wikidata. You can retrieve the image from Wikidata. That means one single query can be executed on different parts, can be executed on different SPARQL endpoints. And then the typical features of a query language, like solution modifiers, like ordering the solutions and slicing. So now that we have such a powerful query language, wouldn't it be nice to query entities with that language? Yes, we have some experimental feature that we're not documenting yet because it's not ready. But consider that query. Starting at a certain isotope, follow the Dodonocleats, one or more steps, and then apply that to an entity type. And you get back the Dodonocleats of that isotope. And that also works for local entities. Yeah? Define your entity store, some things, and there's a class called fruits, and then find all the things of type fruits. And here's the result. So let's have a comparison of SQL and SPARQL. So there's one query I wanted to demonstrate in both languages for comparison. One is find the people, their father, and the city in which their father lives. Yeah? So first in SQL, so you would create a table, or maybe you have that already, that has a city table with the name of the city, and a person table with name of the person and the father, mother, and lives in, and some primary keys. Fill in some data. Yeah? And the query looks like that. You join the person table with itself, and then you join it again with the city table on certain predicates, and you get back the result as expected. Yeah? Try to explain to a little kid how you would write such a query. Yeah, what is a join? Easy, auto product, filtered by a predicate. Yeah. Yeah. Now let's do the same in SPARQL. So here you have the same data set, but prepared for RDF. Yeah. So you have a city. I call it city 1 that has a label Madrid and München and Szomoszcz. And then you have data about people. Yeah. That one person 1 is a person and has that label and lives in that city, and family relations among them. And then this one is the same query, but using SPARQL. And the only thing that you have to look at is that one. a person has father, yeah, and then that father lives in the city. And that is easy to explain. Yeah? You go from a person to the father, and from the father to the city. And all the other things are, well, those things that you get back here are identifiers, and you want the human readable labels. That means for all the variables here, you retrieve the label. Same result, but in my opinion, a simple and easy to understand query. So, wouldn't it be nice to query relational databases using SPARQL? Because what is typically the problem? If you are in an organization that has large relational databases, if someone wants to ask a question against these databases, they would ask their IT department in natural language what they want to know. They would write the query, and a few days later, they would come back with the results. And hopefully, they did not misunderstand the natural language question. Yeah? So if they could query their databases using SPARQL, people might be able to write the queries themselves, because they can think at a conceptual level, yeah, in terms of learning the vocabulary used in the RDF representation, yeah, as opposed to thinking about technical details like how's the data organized in the database. So, and that is one of the future features. Yeah. R2RML is a language for mapping relational databases to RDF. And there are usually two approaches to doing that. Either, once you have such a mapping, you convert your database to an RDF for publication or for loading it into an RDF database, or you create an RDF view, which means you don't do any conversion, but at query time, SPARQL is translated to SQL, and the result is back interpreted into that typical SPARQL format. Yeah? So, and how you would set it up normally is your IT department would look at the database and choose a vocabulary suitable for your data, yeah, and write the mapping, and then either create a view or convert it to RDF data, depending on certain criteria. Like, is the data frequently changing? Then probably you would go with a view of the data. Yeah? And here's an example about weather data, which might be frequently changing. Yeah? So in this example, you create a table in SQL, yeah, of stations and observations which are happening at a certain station and at a certain point in time with a certain, measuring a certain temperature. Yeah, here insert some example data. And then write a mapping from this table to RDF. This looks a little bit big, but your users won't have to do that. It's doing your IT department or some expert. Yeah? But what you can see is here you have a station map that looks at a station table, and here's a template for the IRIs that are created for entries in that table. Yeah? Similar for the observation. There's a map for the observations. Yeah? And one interesting thing is that when you map the date column, you specify a data type. And when you map the temperature column, you also specify a data type. That means after this conversion, you have semantically meaningful information, yeah, as opposed to raw values in the database. Yeah? And now let's do that. So when you create there's a new object or future object, yeah, the database RDF store, yeah, which consists of the database and the mapping. And then you can query, like, give me all the stations. Or using a query string, find the station Madrid, and then an observation in that station. And for this observation, give me the date and the temperature. Yeah? So that means on this date, you had 20 degrees Celsius. Yeah. And the use cases, if you have a large data set that you can't convert, or if it's changing frequently. And here is another example. Yeah. But we don't have to go through that. Yeah. That is one of the future features. Or another interesting future feature is entailment. So let's look at that example. Oh, I better don't evaluate it. Here, this example is a small example. Alfred has a father, Wolfgang. Yeah? And this is metadata about the properties. You say has father has a domain person and a range also person. So now one could wonder, is has father a property? No, by default. However, if you enable RDF entailment, you can infer that has father must be a property. And why that? Because properties appear in the predicate position. Yeah. So this additional triple is implied by the existing triples under RDF entailment. Yeah. So now we could wonder, is Wolfgang a person? We can't say that under RDF entailment because this entailment regime is too weak. However, under RDF schema entailment, we can take additional information into account. That means under this one, we can say that Wolfgang is a person because Wolfgang appeared in the predicate position, and we say that has father has a range of person. So that's why we know that Wolfgang is also a person. That's what we can do under RDF schema entailment. Also other things like if E is in class C1 and C1 is a subclass of C2, then we know that E is also in C2. And OWL is a more complicated language for expressing constraints, relations between classes and properties. And that's my talk. Any questions?